Okay, so let's look at how to create a graph in Excel that has a linear regression curve fit to the data, essentially showing a straight line superimposed onto the data, where that straight line could be used to represent the general shape of the individual data points that you have in your graph. So if we start with our data set here, so we have a data set of x values and y values. We have, in this case here, just example data where we're plotting the position of something as a function of the time. So the first step is to just select the data range that we want to graph, and we go over to the Insert menu. If that's not already highlighted, you might see the Home menu initially highlighted. So select the Insert menu, and then we want to move over here to the various types of charts that we have available to us and go to Scatter. Now in engineering, we generally plot scatter with only markers. Other options are to plot lines or lines with the markers at the same time. In our case here, when you're plotting actual measured values, you want to essentially show only the data points themselves. When you show solid lines or continuous lines, that usually implies that there's some sort of a equation underlying the data, or maybe a theory. In our case here, we're going to be plotting just experimental data points or individual data points at which we make our measurements, and all we have to do is select that, and wham, we have ourselves a graph with all of its default settings. So we have, for example, this data point, which is x equals 1, y equals 3, would correspond to x equals 1, y equals 3 over in this point right here. So fairly quick and fairly easy to create a default graph that has your individual data points shown. But this exercise, we want to focus on recognizing that, okay, these data have a general straight line trend going from the lower left to the upper right. How straight of a line is that? That's one question we can ask. And two, what is the equation of that line if we were to draw that line? And fortunately, Excel has the ability to do some background calculations, and they call it linear regression, and it will come up with a statistical estimation of what the best straight line that you could draw through those data would be. And it will follow the equation of a line, which, y equals mx plus b. Y is the slope times the x value plus the y-intercept. To actually look at these data, it's fairly straightforward. We just click on Layout over here, and then there's all sorts of different things that we can change in the appearance of our graph. We can show different titles, and we can label the axes and things like that. But for the moment, we're just interested in this analysis section called Trendline. So if we click on that, we could just take a shortcut over here, but let's just go down to this More Trendline options. That way I can show you all the different options that we have at our disposal for a trendline. First off, we can choose the different type of line that we have going through the data. We can plot an exponentially shaped line, logarithmic, a polynomial. We can have a second order polynomial, third order polynomial, all sorts of things. Generally, we want to try to choose the simplest regression functional shape as we can find. And in our case here, if we think that it's a straight line, or it should be a straight line, even if the graph doesn't really look like it, if we think it should be a straight line, it's generally good practice to choose just a linear curve fit. And the fact that some of the data points don't actually fall on the line is okay. That's just part of the underlying scatter in the data. So we'll choose a linear curve fit, and we can see a preview of what that line is going to be. It did the calculations, and it said this is the best straight line that can go through that data. What is the equation of that line? And then, good question to ask. Well, go down here and click this little box, display equation on chart. So this here is the equation of that straight line. Y equals 1.4706x plus 0.8137. All right, so right off the bat, we can get ourselves a fairly quick and easy way to figure out what the equation of that straight line is. So there we have it. Now, once you've created your straight line, you can make some modifications just by going, first of all, you have to make sure that you select the box. Right now it is not selected. So select the box of your graph, and that Trendline button will appear again over here. Go back down to the More Trendline options, and we can see display equation on chart. We can also display the r² value on the chart. Oops, we still have our old value from the first time we did that. We can delete that. Let's just start it over. Get rid of our trend lines. We'll go back and we'll create it again. More trend line options once again. Select linear. Now we'll not only show the equation on the chart, but we'll show the r² value on the chart. So the r² tells us how close our straight line model, our idea that, hey, this data might be a straight line, this r squared tells us how close to that straight line our data actually is. An r squared of 1 means it is a perfect fit. It means to use a straight line is a great idea. It really works well. And a value of 0.957 is pretty close to 1. So what it's telling me is that the use of a straight line to represent that data is statistically valid. I mean, it's well justified. So that's all it really takes to get an equation with of a straight line, to get an estimation of how close to a straight line the data is, have the line actually shown with your data right on the graph.